Hey there, I'm Jennifer Pulley, and welcome to another episode of NASA 360. We have a great show lined up for you today. First, we're going to talk about NASA's exploration plans. You know, like where are they headed? Try the moon. We're going back, and Mars. Then, for all you gearheads out there, we're going to show you how IndyCar and NASCAR are using some NASA technologies in racing. But first, let's talk about this behind me. By the end of the next decade, NASA is planning on going back to the moon. Now, technology, it has changed so much since 1969 when they originally landed on the moon. So NASA's been developing new technologies, new spacecraft, new structures to help them get back. And with any new plan like this, huge concern, safety, and it should be. With that being said, NASA has begun testing the new concepts and vehicles to help them get back to the moon. And this thing behind me is part of the testing. It's called the Flight Test Article for the Launch Abort System. What does that mean? Let me help you break it down. The vehicles that NASA will be using in their new exploration plans will look very similar to the Apollo vehicles used back in the 1960s and 70s, but these will be much more advanced. NASA's new spacecraft will include the Ares rockets that will carry crew and cargo into space, the Altair lunar lander that will bring crews down to the lunar surface. And finally, there will be the Orion capsule that will house NASA astronauts during liftoff and return to Earth. So you see, this flight test article is a mock-up of that Orion capsule I was just talking about. Yeah, but why would NASA need a mock-up like this? In the unlikely event that the astronauts need to escape from the launch pad quickly, the launch abort system will lift the Orion capsule away from the danger area, 1 mile in the air and 1 mile downrange. Parachutes will deploy, and the capsule will come down for a landing. So before astronauts fly in this capsule, NASA must test it to be sure it operates properly and that it's safe. That's where the flight test article comes in. NASA can't rely on computer simulations alone. So they need to test a full-scale unmanned version of the craft. It will be strapped onto the escape rocket motor and fired to make sure that everything works as planned. The results of this test will help NASA make sure everything is in working order and give some reassurance that this system will keep the crews safe. By now, if you didn't already know it before, you've heard me say NASA first went to the moon back in 1969. But did you know that tons of the materials developed for those first moon missions can be found in our daily lives? That's right. You can find some NASA-inspired technologies in your home, your car, your computer, even in the packaging for the food we eat. And guess where else they can be found? Try professional sports equipment. There's not a sport around that hasn't been touched by NASA in some way. Now, to help show us that NASA...
Check it out. Right now, NASA is planning missions back to the moon and onto Mars. The capsule NASA will be using is called the Orion. And even though Orion looks similar to the old Apollo capsule, it's a brand new state-of-the-art spacecraft that'll hold between 4 and 6 crew members. Now, if you recall, when the old Apollo capsules returned from the moon, they splashed down into the ocean, right? Well, that worked well for the Apollo. But today, NASA scientists are researching whether the Orion will come down in the ocean or if they wanted to come down on land. Either way, some serious work is going into understanding how to protect astronauts from injury during landing.
Although NASA has tons of data on what astronauts may experience during landing, they're also working with IndyCar to look at their data too. This is because IndyCar has detailed data for every crash since 1996. As you can imagine, when a car hits the wall at 200 miles per hour, the occupant will experience huge G-loads. So it's a no-brainer that IndyCar and NASA would be working hand-in-hand to produce better protection strategies for both drivers and astronauts. NASA will use much of the data to help design optimum seat configurations to help minimize risks to our crews upon re-entry and landing, while IndyCar will benefit by having NASA researchers designing seat configurations that may also help keep race drivers safe. So whether in spacecraft or in race cars, both groups are working hard to provide the best protection for vehicle occupants.
Okay, earlier in the show, we talked about how NASA is planning on sending astronauts back to the moon and then on to Mars, remember? All right, well, Here's a question for you. Where are they going to live once they get there? And most likely, during the first few missions, astronauts will live on the spacecraft that got them there. But as they begin to stay for longer and longer periods of time, NASA's really going to need to provide some permanent living quarters. So are we talking condos? Are we talking apartments on the moon? Not quite. What will astronaut housing look like on the moon and Mars? And how will it be constructed? Let me tell you. Right now, the leading candidate for moon and Mars habitats are something called inflatable structures, like these guys right here. Now, these structures are kind of similar to those giant blow-up bounce houses you might find at your state fair or at a birthday party. However, the inflatable structures that NASA's looking at are as tough as nails. They're hard as steel, and they're able to withstand the rigors of space as well as the different environments of Mars and the moon. I spoke with Judith Watson at NASA Langley to find out how these inflatable structures are going to work.
Inflatables have been around for a long time. If you go back as early as the early satellites like the Echo, that was actually a balloon that we orbited all in space. So it was an inflatable structure. As early as the 1960s, Wernher von Braun was considering using inflatables on a space station orbiting the Earth. So they've been around for a long time. More recently, in the 90s, we started looking at a possibility of one as part of space station to give the astronauts a little bit more room. So it's not that uncommon. It's been around for a while, and now we want to take it and take a look at it. Is it good enough for the astronauts to live in on the moon? We're actually looking at materials like Kevlar and Vectran, which are very sturdy fabric materials. We use a bladder that's a polyethylene coated type material, so it's sort of a rubber coating to it to help hold the atmosphere in. Your Kevlar, your Vectran, which is like webbing, acts as a restraint layer and holds the load. So you have a very sturdy fabric material holding in the atmosphere. Then you put other layers on top of that to protect it thermally from the changes in temperature. It gets quite hot and quite cold on the moon. We also have to look out for radiation problems for the crew. The moon is going to be like living on a vacuum. So you don't have an atmosphere, we don't have air, we have to take that with us. We have the micrometeoroid threat, which means there's small little rocks, varying sizes, that come through very fast at very high speeds, much faster than even a bullet comes through on Earth, that can hit the structure and punch a hole in it. And that's the same whether it's steel, composite, or an inflatable structure. So whatever we put up there, we have to put up a protection layer to protect against that.
Jesus, I have to tell you, I'm dying to touch that. Just see if I can kind of push it. And can we go over?
Sure,
Should I take a look?
Come on over. It can be hard as steel. Right now, it's only pressurized like 0.1 psi.
Right.
We want to go to 9 psi. So that's like going from 1 to 100. So it gets a lot stiffer. So if you push on this, you can push on it a little bit.
Yeah, it has a little give to it.
It gives a little give. But in reality, once you really bring it up in pressure, the way that it's going to be on the moon, it's going to be as hard as steel. To give you an example of it, here's my trusty basketball. Basketballs are basically inflatables in their own right. They have a certain type of material on them. They're actually even coated with rubber, not unlike we're going to coat the inside of this guy. And if you think about it, they're pretty darn hard.
They are.
So they can bounce. So it's going to be a very similar principle. We're going to put enough pressure in there that this thing's going to be very hard.
Judith, if I'm an astronaut on the moon, how do I get into an inflatable structure? If it's pressurized, when I walk into it or go into it, isn't it going to affect the pressure?
It will, and that's why we have airlock. So if you want to step around this way, I can show you the airlock and how it operates. Then we can open the door, and you can step inside. And here you go.
Oh, wow, this is amazing. Earlier you were talking about the bladder.
Yes.
Okay. Describe what you mean by the bladder of this structure.
Okay, the bladder's this inside layer. It's coated in polyethylene, which is like a rubber, and that's to keep the air from going out. The idea is we don't want this even leaking a little bit. Anything in space is going to leak a very small amount.
Right.
So we want them to keep their air as long as possible. So we've got that on the inside, and it usually doesn't maintain the structure, the tension that's caused by the air. It's just here to protect the air from going out.
Okay.
So it's a little bit larger, so there we get little wrinkles sometimes if it's not totally inflated
it's
like it
stretchable.
is right now. It's very stretchable.
Very stretchable.
So that's what the inside is made out of.
All right, Judith, I think we're equalized. We ready to go?
Sure thing.
so cool.
I'm so glad you enjoyed it. Very happy to show it to you.
So we know NASA is not just going to send up these inflatable structures to the moon or Mars without testing them first, but where on Earth do you test these structures to make sure they can withstand the rigors of space? NASA packed an inflatable structure habitat and sent it down to McMurdo Station, Antarctica, where the focus was to see how easy it was to deploy and how it held up under those harsh conditions. A small group unpacked and set up the inflatable, then began to inflate it. Once the inflatable was laid out and secured, about 6 minutes later, it was fully inflated and ready to be used. This is good news because although the conditions are tough down in Antarctica, it will probably be just a little bit harder on the moon, where astronauts have to carry their own oxygen and work inside bulky spacesuits. You may wonder if this inflatable structure can actually hold up on the moon and Mars. Why doesn't NASA just send up rigid structures? Well, there are a lot of reasons, but two of the most important are storage and weight. Right now, this huge inflatable structure can fold up into a very small space for shipment to the moon, and it's considerably lighter than rigid structures. Now, this is important. To land 1 pound of supplies on the lunar surface, NASA must launch 125 pounds of hardware and fuel to get it there. Another benefit is that this inflatable structure can be taken down and redeployed multiple times, permitting exploration beyond the initial landing area. So it looks like NASA is on the right track.